So this is our functional prototype payload. First thing we want to point out is the remove before flight pin, which is just a modified cotter pin shown here in the video. And it's pulled out on the opposite side of the panel using a 17-pound fishing line. And this will also be routed through the entire rocket and pulled out right before launch. Additionally, you can see in this video, the solenoid has cabling long enough to reach the top where the embedded team can control it. And those will be attached using two 540 screws as well on each side to mount to a base, kind of like a board stack. This is our environmental testing demonstration that the RBF pin will not fall out. However, we will not expect any kind of dynamic disturbances prior to launch, but this is just to ensure that the RBF pin will never come out. If you pull the string, it comes out after about 2 pounds of force. The next thing we need to demonstrate is the functionality of the solenoid. So right here, we don't have the patches yet, but the top one is a control, the bottom will have the magnet attached to it via the solenoid right here. What will happen is when activated, the solenoid will transfer the magnet to the bottom of the beam, changing the natural frequency of it. The payload right now is inserted into the rocket. As of now, the bottom half of the rocket is not here, but there will be aluminum foil tape right here as well. And so the payload is resting between two surfaces. Both will be made of aluminum right now. They're both 3D printed. And this will allow it to be compressed using these two threaded rods at the top. So when shaken, you'll notice there's no sound because it is compressed tightly. When taking the payload off, this will obviously be done in reverse order, but because it's compressed, it slides in through the rods when you take this lid off. And this is the aft end side of the rocket, which will attach to our avionics bay. Pull it up. Here is where the payload is. Slides out, it's upside down, and